Every day, millions of passengers and billions of dollars in freight travel across the United States. It is a massive logistics network, powered by heavy steel and high-output diesel engines. But inside the server rooms controlling this traffic, the modern facade disappears. The core operational logic for many of these railroads was written during the Nixon administration. Amtrak's Aero reservation system and the freight management platforms at BNSF and CSX still run on 50-year-old IBM mainframes. These systems have survived because they are engineering marvels. They handle complex, real-time inventory and scheduling with a level of reliability that modern software often struggles to match. The hardware is stable, but the workforce maintaining it has reached a demographic breaking point. These mainframes rely on highly specific languages like IBM ZTPF, COBOL, and MacroAssembler. The architects who built these systems are retiring. Meanwhile, computer science programs are not training a new generation of engineers to read or write 50-year-old assembly code. This skill shortage turns a reliable system into a massive operational risk. The railroads are effectively locked in place, unable to modernize their foundation because the people who understand it are leaving the industry. Replacing a legacy core is difficult because it is buried under decades of digital architecture. A typical railroad network operates in 5 structural layers. It begins with physical tracks at the bottom and moves up through the mainframe core to customer apps. This diagram shows how the Aero reservation system integrates with financial ERP systems and physical signaling. Standard modernization strategies often fail in this environment. A simple lift and shift to the cloud doesn't address the underlying complexity, while a total reboot carries an unacceptable risk of halting the national supply chain. Engineers must find a way to rebuild the digital foundation, all while the massive network stays in constant motion. The industry is turning to a software methodology called the Strangler Fig pattern. Instead of deactivating the mainframe, engineers build modern API gateways and microservices. These act as a digital wrapper surrounding the legacy code, processing data requests before they reach the vintage hardware. This setup allows for a gradual data migration. Information is intercepted and routed into modern cloud data lakehouses, such as Snowflake and Databricks, rather than the old mainframe storage. Over 3 to 7 years, this new architecture slowly takes over the mainframe's workload. Eventually, the legacy system is bypassed entirely and can be safely deactivated. This phased approach provides the zero downtime transition required to protect the national economy during the upgrade. Moving the core workload into the cloud does more than update the hardware. It transforms railroad data from a proprietary legacy format into a standardized stream that modern algorithms can actually read. This transition enables the AI and machine learning layer shown here. By pooling data from across the network, autonomous software agents can monitor operations 24 hours a day. This visibility leads to predictive maintenance. AI models analyze sensor data to identify microscopic stress fractures in tracks or locomotives, allowing for repairs before a derailment occurs. It also towers digital twins. Railroads can now simulate their entire physical network in a virtual environment, testing new freight schedules and routing strategies to find the most efficient path in seconds. The railroad evolves from a reactive hauling mechanism into a proactive, self-optimizing digital network. Reaching this level of intelligence is a massive undertaking. Modernizing a national railroad typically requires an investment between $200 million and $500 million. Every dollar of this budget targets invisible architecture. None of it is spent on new locomotives or miles of steel track. Performing digital surgery on a moving railroad is high-stakes work, but the organizations willing to endure this transformation are the only ones that will define the next 50 years of American transportation.